Hi friends, in this video we will solve the questions from engineering mechanics for your AE Genco TS 100 questions which will be very useful. So definitely you are going to score 4 marks if you solve these 100 questions. Let us solve. The resultant of two equal forces P making an angle theta is given by option B, that is 2P cos theta by 2. Right. A framed structure is perfect if the number of members are equal to. If it is less than, then that is called deficient. Otherwise, it has got another name. So, equal to is the correct answer. Where J is the number of joints. It is perfect if the number of members are equal to 2J minus 3, where J is the number of joints. Right. For example, I have got a 4 bar mechanism. Okay. It has got number of joints 1, 2, 3, 4. How many members should be there? 2j minus 3. 2 into 4 minus 3. 8 minus 3, that is equal to 5. So if it is having 5, then it is a perfect structure. Otherwise, it is a deficient structure. In this case, it is deficient. If the number of forces are acting at a point, the resultant is given by under root of sigma v square plus sigma h square. V is the vertical components square and horizontal components square. Under root of that is going to give the resultant. Okay. Right, friends. The linear acceleration of a body rotating along a circular path of radius r with an angular acceleration of alpha is given by, what is the answer? The answer is B. A is equal to alpha into r. R is the radius of the link length, or link length simply you can say. Okay. So your link will be something like this. Okay. It will be like this. So your link will be like this. It will be rotating, right? For example, alpha. This is the alpha. R is the link length. So this will be tangential acceleration. Okay. For example, I got like this, friends. So I got a link like this. It is alpha making. Okay. So this is the R is the radius of. So this is the tangential acceleration. Okay. So alpha is the what is asking, angular acceleration. Okay. There are two accelerations for the link which I have shown. Tangential, which is directed perpendicular to the link, and tangential, radial along the, which is directed along the length of the link towards the center. The total acceleration is the algebraic sum or vector sum of these two vectors, tangential acceleration and radial acceleration. Moment of inertia of a circular section about an axis perpendicular to the section is, how much it is, friends? Pi d power 4 by 32. So pi by 64 d power 4 plus pi by 64 d power 4. How you have got? Izz is equal to Ixx plus Iyy. Okay, Ixx and Iyy are pi d power 4 by 64. This is the perpendicular axis theorem. According to parallel axis theorem, so relationship between Ig, moment of inertia about center of gravity, and A is the area of the lamina, plane lamina, and H is the distance between the two axes, lamina and the axis about which, lamina central axis, and axis about which we are taking the moment of inertia. In that case, Ip is equal to Ig plus AH square. The friction experienced by a body when at rest is known as static friction. Is called static friction. When it is in motion, it is called dynamic friction. When it is on the point of motion, it is called limiting friction. Coefficient of friction is nothing but it is mu is equal to F by R. R is the reaction and F is the frictional force. The energy possessed by the body for doing work virtue of position is called potential energy. Right? That is the potential energy. If it is by virtue of its velocity, it is called kinetic energy. The coefficient of friction depends upon what? It is going to depend upon all of them. Nature of surfaces, area of contact, and shape of the surfaces, etc. also. Sorry, friends. So here, nature of surfaces, others are not going to influence the coefficient of friction. So these are not correct. So A is the correct answer. Sorry. For any system of covalent forces, the condition for equilibrium. What is this condition for equilibrium? It is going to be all of the above. That means sum of the horizontal components is 0. So algebraic sum means plus and minus. Algebraic sum of vertical components should be 0, and algebraic sum of all the forces, algebraic sum of the moments of the force about any point should be 0. So sigma m0 and sigma f0, sigma f0 includes sigma fx0, sigma fy0. That means horizontal components and vertical components. Center of gravity of a thin hollow cone lies on the axis at a distance of 1/3 of the height above the base. Let us check the answer. Yes, 2/3 from the vertex and 1/3 from the base. The time of flight of a projectile on downward inclined plane depends upon what? So, what is the correct answer? It is going to be C, both A and B. Angle of projection and angle of inclination of the plane. So, alpha and theta also, right? Alpha, angle of projection, and theta, what is that? This is the angle of projection and angle of inclination of the plane, right? Theta is the angle of inclination of the plane. For example, angle of projection, both. In a single threaded worm and worm wheel, the number of teeth on worm is 50, the diameter of the effort wheel is 100 mm, and that of the load drum is 50 mm. The velocity ratio, what is the velocity ratio for this? It is B 100. So how it is B? It is the velocity ratio, distance moved by effort and distance moved by something other, friends. Just please check it. Distance moved by effort and distance moved by the load, like that. The potential energy of a vertically raised body is dash the kinetic energy of a vertically falling body. It should be equal. Whether it's going up, body is going up or coming down, it will be equal. But sum of the energy is constant. What is that? Potential energy and kinetic energy. When a body is freely falling from certain height. So at the bottommost point, it will be having the maximum kinetic energy, and at the topmost point, it will be having the maximum potential energy. In between them, it will be having the sum of potential and kinetic energies. The sum will be constant throughout its height from the ground. A block of mass m1 placed on inclined plane, smooth plane connected by light string passing through over a smooth pulley to mass m2, which moves vertically downwards as shown in the figure. The tension in the string is, so you have to solve it, friends. Actually, you have to go for the equilibrium of the forces. So anyhow, let us see the answer. So it should be m1 m2 by m1 plus m2, right? No. So m1 m2 g into 1 plus sin alpha by m1 m2. That is the correct answer. Right. So you have to solve. You have to take the what you call equilibrium of the vertical load and also horizontal load, or m1 mass m1 and mass m2. M2 is the vertical load. M1 is the horizontal or inclined plane load acting on the inclined plane. Okay. So you have to solve for first tension and then solve for the acceleration by considering either the acceleration of the m2, either the equilibrium of m2 or m1. That is how you have to do. You will get the answer. Okay. Which of the following is not the unit of energy? Okay, so what is not the unit of energy? kg of meter, and these are the watt hours is also unit of energy. Okay, watt hour means joule per second into 3600 seconds. How much? Second goes 3600 joules. Watt hour means, okay. So kg of meter is also unit of energy. Kilocalorie is also heat, unit of heat, which is a form of energy. And what is the unit of only power? What is the unit of power? Which of the following statements is not correct? Let us see the answer. D is not. The sine of the angle of repose is equal to the coefficient of friction. No. Angle of repose is equal to angle of friction. So tan of the angle of friction is equal to coefficient of friction. So not the sine. It is a tangent. T. Tan. The moment of inertia of a hollow circular section as shown below the figure about x-axis. How much it is? Pi by 64 d power 4 minus d power 4 capital D small d. The forces whose lines of action are parallel to each other and act in the same direction are known as like parallel forces. If the direction is opposite, reversed, then they are called unlike parallel forces. Coplanar concurrent forces means the forces should be lying in the plane and they should meet at a point. Coplanar non-concurrent forces means the forces should be lying in the plane but they are not meeting at a point. The velocity ratio in case of an inclined plane inclined at an angle theta to the horizontal and weight being pulled up the inclined plane by vertical effort is, what is this? This is sine theta. So what the situation here is? Situation is something like this. Okay, it is pulled. This is the body. This is mg. This is theta. Sine theta. A block of mass at 20 kg lying on a rough horizontal plane is connected by a light string passing over a smooth pulley to another mass 5 kg which can move freely in the vertical direction as shown in the below figure. The tension in the string will be. So consider the equilibrium of the vertical load and horizontal load or mass 20 kg and 5 kg and 10 kg. First solve for the tension in the string, then either consider 5 kg or 20 kg body and its equilibrium. You are going to get the tension in the string T. Okay, you can also get the acceleration also. So by solving the equilibrium equations for the vertical load and horizontal load or mass 5 kg and 20 kg. So what is the correct answer here? The correct answer is A, increase. So he is asking coefficient of friction. If the coefficient of friction is increased, then definitely tension in the string should also increase. Why? If the coefficient of friction is increasing, the frictional force increases. So to compensate for that, your tension should also increase. So your body is something like this, right? So it will be like that, right? It will be like this. Okay. So because your weight is like this, so here the frictional force will be like this. Frictional force will be, right? So if this increases, T should increase. The skidding away of the vehicle on a level circular path can be avoided if the force of friction between the wheels and the ground is, what is that? Is it equal or greater than or less than? It should be greater than. Otherwise, there is no balance. It should be little above the centrifugal force. The balancing force should always be greater than the disturbing force. That's the logic here. The angle between the two forces of the resultant maximum and minimum respectively are. So when they are 0, they should be added. When they are opposite to each other, they should be subtracted. So maximum is, for example, f1 plus f2. So it is like this. Okay, like this. Okay, so other case is like this. In this case, the resultant is f1 plus f2. In this case, it is f1 minus f2. Here 180 degrees, here 0 degrees. So maximum is when they are collinear but in the same direction. It is minimum when they are collinear but in the opposite direction. The mechanical advantage of lifting machine is the ratio of load lifted to the effort applied. Load lifted to the effort applied. Output input, no. Input output is the efficiency. Distance moved by the effort to the distance moved by the load. Right. The efficiency of a lifting machine is the ratio of, what is this? It is all of the above. All of them will give the efficiency of lifting machine. Output input, work done by the machine to the work done on the machine. Mechanical advantage to the velocity ratio. Okay, N neta is equal to mechanical advantage by velocity ratio. When the spring of a watch is wound, it will possess which energy? It will possess a strain energy, because it is wound means its dimension will be undergoing change. So because of that, it will be having strain energy. Kinetic energy will be possessed if it is moving. Heat energy and electric energy are ruled out. The frequency of oscillation of a compound pendulum, kg radius of gyration about the center axis, and h is equal to distance between the point of suspension of CG of the body. Then what is the frequency of acceleration? So this is a good question, friends. Just check the answer. So what is the answer? I think it should be C. Remember this expression 1 by 2 by under root of gh by kg square plus h square. The velocity of a particle v moving with simple harmonic motion at any instant given by, okay, so w into r square minus y square. I think that is the correct answer. R square minus y square. Okay. R is the, and y is the displacement from the mean position. R is the amplitude, amplitude, maximum displacement. Okay, right, in which your displacement is always acceleration is directed opposite to the direction of the movement or displacement. This is simple harmonic motion, right? When y is equal to 0, it is equal to wr, maximum velocity. Okay, y is equal to 0, starting position. Okay, when y is equal to r, the velocity will be 0, maximum position. So what is the simply harmonic motion? It is the projection of, so this is your example. Okay, so it is moving like this, so you have to project on the x-axis. So that is a projection of circular motion on the horizontal or diameter. That is called the simple harmonic motion. It is like this, friends. So like this, it will be moving like this, right? So you have to always project, okay, onto the x-axis diameter. It is the projection of the motion of the particle onto the diameter. That's called simple harmonic motion. Such type of motion you will be finding in simple pendulums and like that. Okay, right. If a given force or given system of force acting on a body dash the position of the body but keeps in equilibrium, then the effect is to produce internal stress in the body. What is this? It is does not change, does not change, does not change the position of a body. Alright. The maximum height of projectile on a horizontal plane is given by, this is a good question, friends. Remember this. It is equal to u square sine square alpha by 2g. U square sine square alpha by 2g. The maximum frictional force which comes into play when a body just begins to slide over another body is called limiting friction. Limiting friction. That is on the just point of the motion of the body, right? When it has already started, it is called dynamic friction. When it is at rest, even the body is rest on a particular plane, on a surface, one surface over the other. But because of the friction between the two surfaces, even if you apply some force, the body will not be moving. Okay, so when the it will be, the body will be opposed by the surface on which it is lying. Okay, for its motion. Okay, even though but the body is at rest, some frictional force will be acting between the two surfaces. That is called what you call static friction. So when you are going on increasing the force, okay, for example, you got a situation like this. Okay, so I am applying the force, right? So there is a frictional force between these two, even though I am not applying the force, for example. Okay, so that's called static friction. So when you apply the force, it will be start moving. Okay, it will at some point of force, at some force it will be at some force it will start its motion, that point of friction, that point of position. At that point of position, the frictional force between these two body and the surface on which it is lying is called the limiting friction. Okay, but when the body is already set into motion, that is called your dynamic friction. Frictional force, applied force, this is the situation. So what is the correct answer here? A, limiting friction. A V string attached to at two ends at the same horizontal level, and when the central dip is very small approaches following curve. Which curve? It should be parabola. Most of the times, friends, your answers will be parabola, neither hyperbola nor ellipse. The moment of inertia of a solid sphere of mass m and r is, this is a good question, friends, 2 by 5 mr square. Good question. Mr square by 2 will be cylindrical. Body. Okay, two bodies of masses m1 and m2 are hung from the ends of a rope, passing over frictional pulley as shown in the figure. But the acceleration of the string will be, so these questions you have to solve by considering the equilibrium of the m1 mass 1 and m2 mass 2. So then you will get, first of all, solve t for that. Okay, then find out the acceleration of the total system. So by solving those equations, I am going to get the acceleration of the system string will be equal to, this is the correct answer will be, I think it should be B A. It should be A. G into m1 minus m2 by m1 plus m2. According to principle of transmissibility of forces, the effect of force upon a body, what? It will be the same at every point in its on its line of action. So I can for example extend the line of action of a force till any length. So it is same, neither the maximum nor different nor minimum when it acts at the CG of the body. No. Which of the following is the example of a levers of first order? This is a good question, friends. Right? Levers of first order, second order, third order, like that are there. But this is all of them. Arm of man, pair of scissors, pair of clinical tongues, all of them are the example of levers of first order. Levers of first order. Remember this. This is a good question, friends. Normally questions will be asked from the system of levers. There are three system of levers depending upon the position of the load, effort and the fulcrum. Load, effort and the fulcrum. Load, effort and fulcrum. This is fulcrum, load, effort. So relative position between load, effort. If fulcrum is between effort and load, like that, okay. So depending upon that, we have got three types of system of levers, which are the following are vector quantities: displacement, velocity and acceleration, all of them, because all of them are the vectors. A vector is having magnitude and also direction. Which of the following are vector quantities: angular displacement, angular velocity, angular acceleration. So once again, all of them. After all, velocity, acceleration, displacement are all vectors. So whether it is angular or linear, they are all vectors. The CG of a right circular solid cone of height h lies at the following distance. What is this, friends? H by 4. H by 4 from the base. It will be like this. This is CG h by 4. When a body of mass m attains a velocity v from rest in time t, then kinetic energy of translation is what? It is 0.5 mv square. 1 by 2 mv, half mv square, correct? You have seen from our physics also, intermediate. If two bodies having mass m1 and m2 have equal kinetic energies, the moment of a body having m1 is dash the moment of body having m2 greater than. Momentum is equal to mass into velocity, right? So m1 is greater than m2. So definitely the mass which will be having this mass. So let us check the answer once again. Equal kinetic energy. Okay, where velocity is same. So then the moment of the body having mass m1 should be greater than, correct? Greater than, because m1 is greater than m2. naturally the momentum should also be more. Kinetic energy is equal to, friends, kinetic energy is equal to half mv square. Okay, let us say m square v square by m also I can write, yes or no, right? So I can like that, half into momentum. Let us say I am giving the momentum by L, let us say, okay, L square by m. So whichever is having more mass should be having more equal kinetic energy, but the momentum should be more. Anyhow, check that, okay, so if you are having any doubts. The algebraic sum of the resolved parts of a number of forces in a given direction is equal to the resolved part of the resultant in the same direction. This is known as, what is this? Principle of resolution of forces. Resolution. Transmissibility means it is the extension of the line of action of a force till any length. So resolution means something like this. Okay, for example, I got a force, right, F. So I am resolving on the horizontal direction. Let us say F cos theta along the horizontal direction, F sin theta along the vertical direction. This is the principle of resolution of forces. In the shown figure, the angle of inclination of the plane is increased, then the acceleration of the system will. What is this? So it should decrease. It should decrease. So for this, you have to solve the question, friends. Consider the equilibrium of M2 and M1 separately. Write the equilibrium equations. Okay. Right. So for the first body, for the M2 body, what, because that acceleration will be along this direction, M2 into G, okay, minus T is equal to M2 into alpha, for example, right? So for the first body, so it will be, because this will be like this, so it will be like this, for example, okay. So T, you have to consider the equation of T minus M2 G cos theta or sin theta, something like this, okay. This is sin alpha, mg sin alpha, mg sin alpha is equal to m2 alpha. So like that, you have to solve that and then check it. Three forces acting on a rigid body are represented by magnitude, direction and line of action by three sides of a triangle taken. The forces are equivalent to a couple hose moment equal to, what is this? Twice the area of the triangle. Twice the area. This is a good question, friends. Please check it. The MI of hollow circular section about a central axis perpendicular section as compared to MI about horizontal axis is, it is double. Right. So he's asking like this, okay, friends. So what he is asking actually, let us see the answer. Hollow circular section about central hollow circular section, central axis perpendicular section as compared to about the horizontal axis, okay. Perpendicular section is like this, okay. So it will be double. Izz is equal to Iz is equal to Ix plus Iy. So as Ix and Iy are both are equal, 2Ix is equal to Iz, for example, okay. So it should be more or less, check it. It should be B, double. A weight of 100 newtons can be lifted by an effort of 80 newtons. If the velocity ratio is 20, the machine is, what is this? The machine is, what is the correct answer for this here? Reversible. So velocity ratio should be equal to mechanical advantage. A ladder is resting on a rough ground and leaning against a smooth vertical wall. The force of friction will act where? 0 at its upper end. Why? It's a smooth surface. Okay, friends, like this. Your situation is something like this. Okay, ladder. Okay, here he is saying smooth surface. Here it is rough surface. So there will be force of friction here. For example, it will be moving like this. Okay. For example, it will be moving like this. Okay. I have got a ladder. Here the wall is smooth and floor is rough. Okay. If your ladder is moving like this, force of friction will be like this. But here, when the wall surface is smooth, coefficient of friction is 0. So the force of friction will act at where? Only ground only. Is the correct answer? 0 at the upper ends, correct? It should be 0 at the upper end. Because for smooth surfaces, coefficient of friction is equal to 0. So force of friction will also be equal to 0. Force of friction is equal to F is equal to mu into R. When mu is 0, that will be 0. A ladder is resting on smooth ground and leaning against a rough vertical wall. The force of friction will act where? Upward at its upper end. Why? Just now I have shown you, friends. Oh, it is like this. Okay, so here your ladder is like this. So your ladder will be moving down. Okay, it is moving like this. So your ladder will be moving this. So force of friction will be here. Okay, so your on the ground, your ladder will be moving like this. Force of friction will be like this. Opposite. Force of friction will always be opposite to the direction of the motion of the body. The moment of friction of a rectangular section 3 centimeters wide and 4 centimeters depth about x-axis is. What is the correct answer? BD cube by 12. Okay, friends. BD cube by 12. So what is this? 1 by 12 into 3 into 4 cube. Okay. So 3 4s are 4 4s are 16. Correct answer is 16. Correct answer is 16. 1 by 12 into 3 into 4 cube. The product of either force of couple with the arm of the couple is called, what is this? Moment of the couple. Couple itself is a moment, but here he is asking the product of either force of the couple with the arm of the couple. Okay, so couple is also having arm. So it is we are going to call it as moment of the couple. Moment of a force is different. Moment of couple is also, what is a couple? It is equal and opposite forces F. If they are separated by some distance d, they are going to cause a couple, yes or no? It will be rotating like this, right? If the direction is like this, it will be rotating like this. For example, distance is d, right? So now this is called so he is asking the product of either force of the couple with the arm of the couple. Okay, so that's called the moment of the couple. The result part of the resultant of two forces inclined at an angle theta in a given direction is equal to what? Algebraic sum of the result parts of the forces in the given direction. Not sum. Algebraic sum. Some may be plus and some may be minus. In that case, we are going to use the term algebraic sum. It is neither the sum nor difference, or the sum of the forces multiplied by the sine of the theta. Okay. One end of helical spring is fixed while the other end carries a load W which moves with simple harmonic motion. The frequency of motion is given by 1 by 2 pi root z by delta. 1 by 2 pi root z by delta. So the situation is like this, okay. So let us see. Helical spring, okay. So here like this, it will be something like this. Helical spring. I have got a load W like this. So now I have given some displacement here. Then I have set this into vibration, right? So the frequency of oscillation of this spring is given by 1 by 2 by root g by delta. What is the delta? It is the momentary disturbance which I have given for the spring. 1 by 2 pi root g by delta. So if you see the units g, let us say g units are meter per second square. Delta will be meters, okay friends, under root. Okay, so meter goes away, 1 by second square 100 root at a 1 by second. So is it not the uh, unit of frequency? So sometimes units will also fetch you a lot of things. Okay, delta by g is not going to give the answer. So now the question is between 1 by 2 pi or 2 pi. So we know that omega is equal to 2 pi f. Okay, 2 pi f. So f is equal to 1 by 2 pi into omega. Omega is equal to root g by delta. So like that, I am going to get the answer for this. The moment of inertia of a sphere of mass m and radius are about an axis tangential to this. This is a good question, friends. 7 by 5 mr square. Please remember. So he's asking the question like this. Okay. So here this is the CG axis. This is the axis about which he is asking the moment of inertia. How you are going to get 2 by 5 mr square plus mr square. Okay, so 5 into 7 by 5 mr square. So how I am going to this? You get this. Some moment of inertia parallel axis theorem. You have to apply the parallel axis theorem. This is axis, right? So the moment of inertia about this axis will be equal to moment of inertia about this axis plus m into r square. The distance between axis is r, radius, and of course m is m, its mass. So about this axis it is 2 by 5 mr square. So about this axis it will be, let us say, m. This is the CG axis. Okay. So then 2 by 5 mr square about the g axis plus m into distance between the axis r square. So if you solve this, 7 by 5 mr square is the correct answer. If the masses of both the bodies as shown the below are reduced to 50%, the tension in the string will be, so it should be, I think, okay, so friends, it should be half. So once again, consider the equilibrium of m1 and m2, solve for tension, solve for t, and then you get the acceleration, then get the result, required things. The range of projectile will be maximum for a given velocity of projectile when the angle of projection is, this is a good question, friends. There is a particular condition for that is there, 45 plus beta by 2, 45 plus beta by 2. Moment of inertia of a rectangle section having width b and depth about axis passing through CG and parallel to depth. What is this? It should be db cube by 12. It should be db cube by 12. So he is asking what? He is asking width b and depth, CG and parallel to depth. So he is asking this. So this will be like this. Okay, this is your b and this is d. He is asking the moment of inertia parallel to this axis. So you have to take the parallel dimension. This is the perpendicular dimension. Okay, because he is asking this axis. So it should be db cube by 12, not bd cube by 12. Had it been this axis, it would have been bd cube by 12. So always parallel dimension into perpendicular dimension whole cube by 12. Moment of inertia of a rectangular section having width b and depth about an axis passing through CG and parallel to width b is, it should be bd cube by 12. Just now I told you, bd cube by 12. A smooth cylinder lying on a dash is in neutral equilibrium. So this is a good question, friends. It should be horizontal surface. Horizontal surface. Neither the curved surface nor convex surface. Neutral equilibrium. The resultant of the following three couples, 20 kg force, 0.5 arm, positive sense, 30 kg force, 1 m arm, negative sense, and 40 kg force, 0.25 mm, positive sense having arm of 0.5 will be. So you have to do some 20 into 0.5 minus 30 into 1 plus 40 into 2.25. If you solve this, you are going to get algebraic sum you are doing. Okay, you should get 20 kg in negative sense, negative value you are going to get. A couple produces, what is this? It's a good question, friends. Couple produces rotational motion. Couple always try to rotate, not translatory, combine translatory and rotational no. So just now I was referring to you, right? For example, I have a situation like this, for example, okay. So I got a force like this, I got a force like this, or I got a force like this, I got a force like this. There is a distance between them. Either it will rotate like this or rotate like this. Clockwise movement or anti-clockwise movement. So it is not going to produce any translatory motion. A force acting on a body may change its motion, balance the force, other force acting on it, retard its motion, all of the above. So these are the characteristics of a force, friends. So all of them are going to be applicable to the force. A force while acting on a body may, what is this? Once again, it should be all of them. Change its motion, balance the forces already, give rise to the internal stresses. So the third one is the only different one from the previous question. So all of them is the correct answer. Mass moment of inertia of a thin rod about its one end is dash the mass moment of inertia of the same rod about its midpoint 4 times. Right. ml square by 12, ml square by 3, ml square by 12, ml square by 12, ml square by 3. So into 4 I am going to get ml square by 3. So this is what he is asking, friends. So he is asking like this, okay. I got a rod like this. This is the point and this is the point, okay. So about this it is ml square by 12. About this, okay. About this it should be ml square by 3. So it should be 4 times. The ratio is 4 times. According to Lamy's theorem, what is the correct answer? If three forces acting at a point are in equilibrium, then each force is proportional to the sine of the angle between the other two. So these other three are not correct answers. So what is the correct representation for P by sine alpha is equal to Q by sine beta is equal to R by sine gamma. If my situation is like this. Alpha, beta, gamma, P, Q, R. According to principle of moments, what is the correct answer? If a system of covalent forces is in equilibrium, then the algebraic sum of their moments about any point in their plane is 0. Is also called Varignon theorem. Okay, friends, Varignon theorem also says the same thing. The velocity of a body on reaching the ground from a height h is root 2 gh. Root 2 gh. Root 2 gh. Okay. Root 2 gh. So it is how I am going to get v square minus u square is equal to 2as, right? V square minus u square is equal to u square is equal to 2gh. Okay, u is equal to 0. V square is equal to 2gh because v is equal to root 2gh because it is freely falling. The force induced in the string AB due to the load W as shown in the figure is what? It is W cosec theta. W cosec theta. W cosec theta. So here it will be balanced by, this is, let us say, T cos theta, T sin theta. Here T cos theta, T sin theta. Okay, friends? T sin theta is equal to T sin theta is equal to W. Okay, so T is equal to W by sin theta. that is cosec theta. 1 by sin theta is equal to cosec theta. Vertical component of the tension is balanced by the W, weight. An ideal machine is one whose efficiency 100%. An ideal machine is one whose efficiency is 100%. A heavy ladder resting on floor and against the vertical wall may not be in equilibrium if how the floor and wall both are smooth surfaces, right? In the floor and wall, one should be rough and one should be smooth. Even if both are rough, it is no problem. It is going to be in equilibrium. But if both are smooth surfaces, it will be sliding completely. It will not be in equilibrium. In the equation of virtual work, following forces is neglected. What are the forces? All of them. Reaction of any smooth surface with which body is in contact, reaction of a rough surface of a body which rolls on it without slipping, reaction at a point on an axis fixed in space around which body is constant to turn. All of them are the correct answers. The equivalent length of a simple pendulum which gives the same frequency as compound pendulum. Is this a good question, friends? Just check it. This is your B, K square, H square by H. K square, Kg square plus H square by H. When the lift is right, so H by Kg square plus H square is not dimensionally correct. He is asking the equivalent length, so length dimension should be square by some length dimension. Okay, so you should be getting a doubt between I think B and D. Okay, but so D is not correct because both are H square, so it should be B only. So by knowing the correct dimensions, you can answer some of the questions in your question paper. When the lift is moving upwards with some acceleration, the pressure exerted by man, what is this? It is directly proportional to its acceleration. So here, okay, right. The force required to move the body up the plane will be minimum if it makes an angle with the inclined plane. Dash of friction should be equal. So phi should be equal to alpha. Phi should be equal to alpha. So that's called angle of repose also. Phi is the angle of friction and alpha is the the angle made by the plane with respect to the horizontal. This is the horizontal. This is the body. Okay, right. As you go on increasing the angle, so at some point of alpha, it will start sliding. This will be equal to friction angle. That's the coefficient of tan phi is equal to mu. So mu is equal to tan inverse phi. That is the coefficient of friction between the body and the surface. Angle of friction. What is angle of friction? Angle between the normal reaction and the resultant of normal reaction and limiting friction. If the tension in the cable supporting a lift moving downwards is half the tension when the moving upwards, the acceleration of the lift is, it is D, none of the above. I think none of the M is going to give the correct answer. A particle moves along a straight line such that the distance traversed by 10 seconds is this. The acceleration of the particle will be given by the equation. He is given the x is equal to t cube minus 4t square. So acceleration velocity is equal to dx by dt. Okay, 3t square minus 8t. Once again, if you derive once again, it is going to be 6t minus 8 d square x by dt square. So twice derivation of the displacement is going to give, it should be t, 6t friends. It is wrongly printed. It is wrongly printed as f. No, it is not f. It is T. 6T minus 8. When two elastic bodies collide with each other, what is going to happen? Two bodies will momentarily come to rest after collision. Two bodies tend to compress and deform at the surface of the contact. Two bodies begin to regain their origin because it's a elastic collision. So the correct answer is D. In the elastic collision, kinetic energy is conserved and momentum is also conserved. A number of forces acting at a point will be in equilibrium if sum of the result parts in the vertical direction is 0. Sum of the forces cannot be 0, friends. Algebraic sum can be 0. Some forces should be positive, some forces should be negative. And equal inclined also not correct. So correct answer is only C. The moment of inertia of a square about an axis through center of gravity is. So he is asking square, center of gravity, A. What is this? 1 by 12, A cube into A. B is A and also D is also A compared to a rectangle. So A power 4 by 12. A power 4 by 12. The below figure shows the two equal forces acting at right angles at a point. The value of force or acting along their bisector and opposite direction is, it is C, root 2p. The maximum mechanical advantage of a lifting machine is, this is a good question, friends. It is C, 1 by m. 1 by m. Maximum mechanical advantage. Velocity ratio, okay, friends. According to law of triangular forces, what is the correct answer? If three forces acting upon a particle are represented in maximum direction by the three sides of a triangle, then taken in order they will be in equilibrium. So, you should take them in order. For example, like this, okay. So, like this, and like this, right? Resultant will be like this. Once again, this is the resultant, okay. If you are applying a force like this, opposite to the resultant, it will be in equilibrium. So, they should be taken in order. 1, 2, 3. So, correct answer is a smooth cylinder lying on its convex surface remains in which equilibrium? Unstable equilibrium. These are the good question, friends. Unstable. Stable when it was horizontal or plane. Horizontal plane or lying on the ground. So here like this, okay. Right. Now he is asking convex. Now he is saying convex. Convex. Unstable equilibrium. Concave. Stable equilibrium. Neutral equilibrium. For example, your body is, okay, it can be like this on horizontal plane or convex plane or concave plane. In concave plane, it will be stable equilibrium. Center of percussion, this is a good question, friends. The point of application of the resultant of all the forces tending to cause the body to rotate about a certain axis. Center of percussion, the point of CG, no. Point of metacenter. What is metacenter? B, so I got a like this, BGM. B center of buoyancy, G center of gravity, M meta center. Center of buoyancy, for example, I have got a body which is immersed under the your liquid. So it has got a center of gravity, right? Immersed position. This is called center of buoyancy. for total body center of gravity. Okay, if it is given some angular displacement from its original position, it will come back, try to come back to its original position, right? So it will be appearing to be rotating about some point, that is called your meta center. So depending upon the relative position of the BGM, I have got equilibrium, unstable equilibrium, stable equilibrium, and neutral equilibrium. So your body will be neutral equilibrium, both G and M are at the same level. Okay, this will be, this is here, it is unstable equilibrium, right? Stable equilibrium, like that. Relative position between the, but here center of percussion is asking. What is this? The point of application of the resultant of all the forces tending to cause a body to rotate about a certain axis. The linear velocity of a body rotating regular at a w radians per second along a circular path of r is given by v is equal to r omega. V is equal to r omega. During elastic impact, the relative velocity of the two bodies after the impact is dash the relative velocity of the two bodies before impact. What is this? Equal and opposite to. Equal and opposite to. So he is asking about the before and after impact. Before and after impact. He is referring to elastic impact. In the elastic impact, both friends, momentum and kinetic energy both are conserved. That means kinetic energy before impact should be sum of the kinetic energy before the impact should be equal to sum of the kinetic energy after the impact. Similarly, sum of the momentum of the two bodies before impact should be equal to sum of the momentum of the bodies after impact. These two principles should be holding good in the elastic impact or collision. So, whenever you get elastic, so go for equal and opposite. Equal. For a self-locking machine, the efficiency must be less than 50 friends. Always self-locking. The efficiency must be less than 50%. You will get something like 1 by 2, or some minus term you will get. Okay, 1 by 2, some term. Okay, in terms of angles. Okay, so maximum should be 50%. So any efficiency should be less than some figure here. It is less than 50%. Less than 50%. Coefficient of friction depends upon what? It is going to depend upon nature of the surfaces only. This is a good question, friends. This is not, this is not, this is not. Only nature of surfaces. For two pair of surfaces, it is a constant and it is different and a unique coefficient of friction. Coefficient of friction is the what? It is the ratio of limiting friction normal reaction. Limiting friction normal reaction. Okay, so it is mu is equal to F by R, tangential force by reaction force. Pick up the incorrect statement from the following. The CG of the circle is at the center, CG of triangle is at the intersection of medians, CG of rectangle at the intersection of the diagonals, CG of a semicircle is at the distance of R by 2 from the center. No, it should be semicircle. So it will be 4R by 3 pi. 4R by 3 pi. It is not R by 2. Okay, friends? So R by 2 means how much? It will be something above like this. Okay, just like that. Okay. So 4R by 3 pi. But others are correct. Circle center. For circle, it will be at the center. For triangle, it will be at the medians. Rectangle, it will be at the diagonal. This is CG. This is CG. This is CG. The ratio of limiting friction normal reaction is known as coefficient of friction, friends. So always there is a confusion. So it should be coefficient of friction, neither the angle of friction nor angle of repose nor sliding friction. Okay, what is angle of friction? Angle of friction is nothing but phi. It will be equal to angle of repose, alpha. What is alpha? Angle of repose. I have got a body like this is alpha. So as increase alpha, at certain alpha, this body will be sliding down. So otherwise, below this alpha, for example, like this I got, okay, it will be in equilibrium with it is not moving actually. So the angle alpha at which the equilibrium of the body over the surface is disturbed, it will start sliding, is known as the angle of friction, and it should be equal to angle of friction should be equal to angle of repose. Phi is equal to alpha. Least force required to draw a body of the inclined plane is W sine plane angle, plane inclination plus friction inclination applied in the direction. Where is this? It is an angle equal to angle of friction to the inclined plane. Non-concurrent concurrent forces are those forces which, what is the correct answer? Meet at one point, but their lines of action do not lie on the same plane. Meet at point means concurrent. Non-coplanar means they are not lying the same plane. By looking at the words, you can make out the correct answer. Coplanar concurrent forces are those which forces meet at point, but the line of action do not no meet at point one. Their line of action of line on the same plane. This is the correct answer. Okay, friends. This is the correct answer. Non-coplanar, non-coplanar. So both are not meeting. Neither do not meet and do not lie in the same plane. Answer is the B. A pendulum which executes 1 beat per second is known as. This is a good question, friends. Seconds pendulum. It is seconds pendulum. Neither the compound, not simple, not torsional pendulum. It is seconds pendulum. D'Alembert's principle is used for. This is a good question, friends. Once again, reducing a problem of kinetics to equivalent statics problem. D'Alembert's principle. Neither the determining the stresses in the stability of the floating bodies, designing safe structures, reducing the problem of kinetics to equivalent statics problem. So there is a reactive force, active force, something like that. Okay, sum of the active and reactive forces should be equal to 0. D'Alembert's principle. Center of gravity of a solid cone lies on the axis at a height 1/3, 1/4. Okay, friends. So I have got a cone like this, 1/4 from the height. This is your height. 1/4. This is your G. This will be 3/4. 3/4 H. 3/4 H from the vertex and 1/4 from the base. 1/4 from the base. In the lever of third order, W, load and effort and fulcrum are oriented as follows. So, just now I was referring to. So, W between P and F, load between the effort P and fulcrum F. So, this is your third order. So, how it will be like this? If this is your fulcrum, always will be at the center F and P. P and F. Okay, so here F, P and F, W. This is W. Okay, let us draw it once again. W between P and F. P and F. W. Or W. Okay. The ideal angle of banking provided on the curves on the road depends upon what? Velocity square of the vehicle. Velocity square of the vehicle. Centrifugal force is going to coming into force, friends. So to counter that, so your roads are banked. So instead of being laid like this, they'll be raised something like, okay, this is alpha angle of elevation compared to horizontal, right? So it is going to depend upon the square of the velocity. Square of the velocity. Okay, friends, in this video we have seen 100 questions from your engineering mechanics first topic in your syllabus for AE TS Genco. In the next video we will see some more questions from yet another good topic which will be useful for your AE TS Genco. Okay, so let us meet in the next video.